containers have been dominating a lot of the cloud native world. The adoption has been of application container technology kind of like increasing at a remarkable pace. We're seeing that, all around Docker reports, Docker themselves reports, more than probably 1 billion weekly container downloads every 2 weeks, probably more now. So what's a better way to just go ahead and start and discussing what are best practices on building your Docker images? So to that end, this is why I'm here today, meeting all of you and having fun talking with you. My name is Liran. I'm from Israel. I'm a developer advocate at SNYK, where we build developer-friendly security tools to help empower developers to find and fix open source security issues in their projects, in their containers, Kubernetes configuration, and so on. I'm actively involved in security through many activities. One of them is the Node Security Working Group, OWASP projects, been writing a couple of books myself as well. So been kind of like around this AppSec scene for quite a bit. If you have any questions, want to ping me afterwards, I'm on Twitter. Reach out. Definitely, if you have any questions during this talk, just unmute. You can stop me and ask. I'd love for this to be more of a conversation and dialogue rather than just me blubbering around for the next 45 minutes or so. But yeah, with that said, our first best practice is, it sounds easy. I'll show you why it's not that easy. But you probably even heard about it and you even maybe try to practice it, right? It's like basically being able to create and use minimal base images. That means you're trying to get your Docker base images to start with, something that has a minimal size footprint, but also a minimal dependencies, open source applications that are installed on it footprint. And that makes sense, but it's not always as I'd say as intuitive as you'd imagine. And I think for me as Phil, as a developer, when I started using Docker, I altered my Docker file, and the easiest thing for me was to do, I'm a Node developer, so for me it was from Node, right? Just using the stock Node image. And that has been my default without really understanding what exactly am I pulling in, any dependencies that's going in there, if my project actually requires those dependencies and system libraries that come with that package, with that Docker base image. Also, what is from Node? That's basically an alias to the latest built image. And that, even without putting security aside of what it actually means, there's also the issue of, am I getting consistent builds? Because every time I will rebuild that image in CI, I might be pulling in new image digests of the node base image as they push in more and more of them. So it's not really consistent builds either. So there's a reason for preferring minimal base images. And as you've seen with the small quiz, right? If we take a lot of Docker images, we'll probably find, even if at the top 10 of those Docker base images and Docker Hub, we're probably going to find some vulnerabilities in them, because they ship, within themselves, they ship a lot of open source packages in the form of system libraries and in the form of like toolchain that exists. Even the runtime itself, if you're using Node as a runtime or Java or anything else, that could have vulnerabilities within it. So understanding which base image to use is really crucial. And the fact that all of those base images are then going to be wrapped up, in some kind of like a container image that is a base of maybe Ubuntu or Red Hat or Debian, or, you could try to go for maybe smaller ones like Alpine and maybe DistroLess as well. There are many possibilities, but at the end of the day, if you're taking a stock one and you're not entirely sure what exactly you're picking in, you might be getting one that has a lot of vulnerabilities. And we're seeing a lot of, trending up CVEs in what we find in this ecosystem. So we're going to get back to this concept of Docker base images and the security of this, but let's move on. So the next up is, least privileged users on my Docker container. But the thing is, when you use a Docker file, you usually, you may not specify a user directive, and that means that it's going to, the Docker engine is basically going to default all of the Docker running the processes and, making any changes, any directives in the Docker file being used as the root user itself, which means this is kind of like an insecure default. Now, it again sounds kind of obvious, but I've seen a lot of Docker files which don't have do not have this guarantee where you're using a least privileged user. So how do you fix it? So first of all, you could use, if you're using something like an Ubuntu image, like a stock image, you could go ahead and basically just add, like you're seeing in my third line of directive, I add a new group, I add a new user to it, and I make sure that at the end of my directives before I'm actually executing the process like here, I'm actually switching to that one. So usually runtile basically switches to this one. If you're using other base images, like say Alpine, it actually already comes with a least privileged user in it already. So you just need to say, this all of this should be running as a user node. That's the least privileged user, and you're using it. That's it. And at that point, there are runtime issues or concerns that you should be worried about in terms of capabilities that a container has and so on. If you're using Kubernetes or something like that. But at least for the sake of the running container, the way that you build it, the ownership of the files within it, and the process that it's running, that's going to be a least privileged user. So if someone was able to, compromise the app itself, they would then need to get a privilege escalation towards the root user, a super user on the system itself, to do more harm, which is another a level of protection that you have when you're using a least privileged user. The other thing is in just enabling 2FA, right? Enabling 2FA to our supply chain. So we're using a lot of open source today to build our projects, to build containers. This is the foundation of many software being built today. And as such, that means that we are very much susceptible to issues or security concerns related to this supply chain. Now, this supply chain could be anything from if I'm a Node or JavaScript developer, I'm a React developer, Vue developer, whatever, all of this. As an example, I probably am using NPM a lot. That means I'm using packages that other people have built. And if someone is able to compromise one of these packages, maybe they are able to get themselves into my project, right? And do funny things there. The thing is, that's not really a scary story for that I just made up. It's really happened, right? We have a bunch of examples, starting with the event stream incident from a couple of years ago, which gets downloaded millions of times. And there was a very sophisticated and surgical attack that targeted developers of a Bitcoin application, wallet application that someone built. And they actually targeted developers with a dev dependency in which they were able to compromise the actual package itself. They did it through social engineering. But there are other cases like mail parser, which was, which gets downloaded 500,000 times a month. And it is a package that if you installed it, you might have gotten a vulnerable dependency in that package tree that someone was able to push in. And they did that by basically being able to compromise the package itself. So the user that actually, or the developer, the maintainer that actually maintained that package did not use, for example, two-factor authentication, did not have a secure password. All of this basically led to the fact that they were able to compromise it. And there's more and more of these stories. I have a list of them that I maintain and so on. I can tell it's always just growing and growing. So at the very least, we need to now enable 2FA. So the 2FA concept here is, for all of us being citizens in this open source ecosystem, is really about the fact that, I think that, when I use the node base image or an Ubuntu base image, this image is precious to me, right? I want to make sure that no one else was able to compromise and create or push a base image of that repository of Ubuntu or Node, for example, and push anything malicious there. Like, by the way, it's been stories again with the Docker ecosystem now of compromising Docker base images in which they mined cryptocurrency in the background when they were running. So I want to make sure that the authors, the maintainers, the developers working on them are actually secure in their accounts, configurations, and so on, bringing us to 2FA. Now let's look at the state of 2FA for the NPM registry. This is definitely a few years back, so not super up to date, but I think it hadn't changed, entirely too much. Right? This is not 80% of the developers probably today. Again, this is my assumption, but as to give you like a reference of what's going on here, we have tracked 7% of all developers in NPM by around 2018, 2019 that have enabled two-factor authentication when two-factor authentication actually existed on the NPM registries since 2017. So 2 years have gone, and a small percent of developers have enabled it. So that's why I always repeat this in my talk. So people actually go after this and enable two-factor authentication to their GitHubs, to their NPM, all of those areas where this is actually important. But what is the state of 2FA in the Docker ecosystem? Well, up to October 1st, 2019, not that far back, there have been zero people of developers who have been basically enabling 2FA because there was no 2FA as a platform, as a mechanism on an ecosystem that gets, like we said, billions of downloads of application images every couple of weeks. And so this has been definitely something that has been recognized by the Docker organization, and they have chimed in, and it took a while, but then they did announce that they added it. So one takeaway here after this talk, of course, is if you do not have 2FA enabled for your account, definitely go in and enable it across the different supply chain ecosystems that you're working on, whether that's Docker npm, Ruby gems, or anything else. So my next step is going to be about how do we keep secrets from getting into our base images. So for example, let's say that we're building an image and we need to pull in some images, some artifacts out of it. If we need to do it, then how do we make sure that the way that we actually download or use the private artifacts that we need to pull into a container don't actually keep the secrets within the container itself? So here's an example of what I'm just talking about here. It's a pretty stock one, right? This is a node example. So what I need to do is I have a private packages on npm, if so to say, of libraries that I want to build, in my team, in my organization, that I don't want others to use. So that makes sense, right? IP and all of that. And for that means that only me, my user, my team can actually access and download them to the container itself when they need to install and run the application, or prepare it. So that's why in this example, almost at the one line before the last, I basically add the token here, the npm token, from maybe an environment variable, maybe I get it there from a build argument, maybe I get it there from just sticking it in the Docker file itself, whatever, but it's there, right? That's what I need to do. But at that point, when I have this image like that, that image basically has now a reference, right? Let alone to the file, to the end, to the token basically existing in the .npmrc file when I install it. So now that base image is, not really secure. So one way of doing it, if you heard about, multi-stage build, it's pretty common today. It allows us to do, a few things. There's definitely a few benefits there. One of them is, at the very least, I can have a very big image like that, that top part, which says, from node 12 as build, right? That bigger image. Which I need cross toolchain compilation. I need, just to see if I have native modules and stuff like that, the GNU C compiler and so on. And then I have at the bottom part here, I have a slimmer image, right? I have a much smaller image with less dependency footprint and things like that. Now, the thing is, it allows me also to basically be able to say, well, that top image that I use is, it's going to have that token inside it. That's the way that I have done it before. But that top image, it gets discarded. The actual Docker-based image that you're creating for your, for your process, for your service, is going to be made out of the second one, the bottom part. So what I'm basically doing is I'm using the top one to create it and pull in anything that I need. And then when I'm building the second base image, the final one for production, I'm actually going to copy the artifacts that I installed and created, and what I needed to do there from the first stage into the second one. So basically, multi-stage base image allow me to create this kind of secure way of managing my secrets. That image, or still some caveats there, that base image at the top is not really left anywhere except like a discarded image on the host that basically built it. So you still need to purge it if you want to keep things very secure. But there are actually better way of doing that even today with an experimental feature called BuildKit, which, and if you're on the latest Docker engine, it should be available by default or enabled by default. And that's the way to basically mount secrets into your base containers. So they're not left in any environment variables residue. They're not left on the image itself. You're basically mounting it for a specific run directive for a specific layer of the Docker-based image, and then it's gone. So this would be the most ideal, optimal way of doing that. Next one, right? Finding and fixing, basically also monitoring for new open source vulnerabilities in your OS. So let's see, as we get, this is where we get back into that, preferring base minimal images, which is, it's easy to say, it's sometimes really hard to do, and we'll see why. So first of all, to understand that, this is an example for the node project. So the node project itself, it it has a specific working group, the Docker working group, that is in charge of building these, formal, official, so-called images that we're pulling in from. Now, the thing is, when that working group makes a decision to base the Docker base image on top of another base image, right, Debian or Ubuntu in a specific tag, that really, really matters. So you can see that there was a point in time in which the node base image was based on Debian Jesse, and that specifically, like choosing that base image to build the official node image, actually brings in by default almost 700 vulnerabilities into the container. So by making a choice of using, maybe for example, I won't say Debian C because we don't want to build on unstables, but we could have chosen a different maybe version of an OS, like one of the Ubuntu's or something else. We would have a much lower attack surface in terms of the vulnerabilities that exist by default on the container. So this is all called build pack depths. If you go to the node, the Docker working group node project on GitHub, you'll see it. And we've been asking, SNYK has been running this annual State of Open Source Security Report, and you can see from last year. So we've been asking a few questions. How do people like treat Docker-related security? So one of them has been, when do you actually scan your Docker-based image for, open source vulnerabilities? And as you can see, like 50% don't actually do it, right? So that's an alarming number of people who don't actually, scan periodically their containers to fix them. And it's rather, upsetting, just because it's an easy thing to do. You can choose, whatever tool you want. If you use something, as SNYK, which is, open source and free to use, you can just run a command that will give you, run SNYK test with your Docker base image name, path to your Docker file, and basically it will show you all of the vulnerabilities that exist. And here is, I did it. I imported basically a project in the SNYK UI into from like Docker Hub into my account. And this is, I'm going to focus on this for a second to give you why like there's like a lot of I would say frustration in fixing issues, right? Let's say a tool like SNYK or anything else gives you this data that you have 862 vulnerabilities in your Docker image. At that point, this is where frustration really grows, right? You have no idea what to do at this point. Should I move from node to node 10 to node 15 to node 16 to node 10 dash slim, Alpine, whatever? I don't know. Like if you go there, do I actually have better? Is my condition gonna be better or worse? So this is why I like the idea where SNYK kind of like helps you do that. It tells you your base image is Node 10.4.0, a specific version of Node, and if you make minor upgrades or major upgrades or even alternative upgrades, you can actually reduce that attack surface from maybe hundreds of vulnerabilities like 862 in your current image to perhaps 54 vulnerabilities, which is not perfect, but hey, we sometimes the name of the game is not really fix everything, stop everything, don't do anything until you like fix everything. It's not the name of the game. Sometimes it's prioritizing, right? Making sure you actually address the critical fixes much faster than than anything else. So with that said, what we've actually looked at into SNYK is how users actually how do they actually remediate vulnerabilities. And one thing that we've seen is that fixing can really be easy if you know which base image to use, right? That's what we basically said. So 44% of those Docker image vulnerabilities, they can be fixed if you just swap the base image, if you just move from node 10 to node 15 or node 15 Steam or whatever was in that example. And there is a lot of variance in terms of which base image tag you're using. So if you're using, Node 10 versus Node 10 Slim versus Node 10 Alpine, you can see the amount of variance in the vulnerabilities that exist on the container image by default. So that's why understanding which base image you need to choose and use is so critical, because your starting point could either be like super bad or very good. The other aspect of basically, I would say, keeping a security hygiene of your your Docker base image is with regards to, depends of what you're doing with that base image. But if, for example, you're doing, one of your practices when building the Docker base image is that you do apt-get update and apt-get, upgrade and all of those things to kind of like fetch all the data that you need to put on it, like if it's specific tools and stuff like that. If you're doing that, then if you're actually rebuilding often, you will basically fix it, right? At the amount of 20% of those vulnerabilities just by rebuilding them. So, and that makes sense, right? Because if you build it at some point, it has, a specific set of vulnerabilities. But then if you rebuild it, a month later, you basically pull in new,
this is
yeah,
what's the copy? Yeah.
Okay, added a person to mute so we don't have that noise in the background. So yeah, so if you basically have that practice of apt get upgrades, in a sense, makes sense. Like I said before, if you want to practice that, then it also makes sense to rebuild it often, so you can pull in new versions of your possibly vulnerable packages. Another interesting question that we ask, and interesting result to an extent, is how do you find out about new vulnerabilities in your deployed containers? So this is again like an example of sometimes the containers that we have in our for me as a developer in like my development environment, or like my one microservice, is not the same as it is deployed into into somewhere in production, or across different services. The reason for that is that there is a drift, right? There is a lag between when I actually build the base image, a Docker base image, to when I deploy it. And at that point, it's actually very critical to say, well, if I'm deploying, for example, Kubernetes pods out of Docker base images, out of like a repository in Docker Hub, I actually want to monitor not only during development to run like a SNYK container test or something like that on my Docker base image and my dev environment, but I also want to run it also on the images built and pushed into my repository, because that probably represents a better in terms of like up-to-date state of what will be deployed the next time that the orchestrator will need to push in an image into production. And again, that's like super easy, right? If you're using something like SNYK, just install the CLI, do SNYK monitor for your Docker image that you're using. It will take the snapshot, push it into the cloud, into the SaaS app, and will send you notification, Slack or whatever, when there are new vulnerabilities and so on. So you can actually track it. But I'm talking a lot about vulnerability and the security of containers, and I can understand that a lot of you, this sounds a lot of like abstract, and what can actually happen, right? What can actually go wrong from having vulnerabilities in container images, right? In these open source dependencies. So to show you an example of what could actually go wrong, I wanted to find a specific use case which others have used before. So I'm not really making anything up here. So I found this YouTube video on YouTube from Google Cloud, Google I/O 2017. So a few years back, where they wanted to like kind of promote Firebase, and they showed a Node.js application that they've built on Firebase, and how it does what it does. Those of you who have been like staring at this screenshot for a while and may have this red flag now. Is it coming up? Kind of like lighting up for something kind of like smelly that goes on here. I'm gonna switch to show you exactly what it is if you haven't caught it yet. That's basically this line, and this is like a Node app that was presented in Google I/O a few years back. And using this method to basically convert images using the ImageMagick library. Now, ImageMagick is a set of library, but it's not really just the library. It's a tool. It's a runtime. It's a set of different libraries. It has bindings with other libraries like GhostScript and so many other things. So it's like an entire attack surface that you'd probably want to protect against. But unfortunately, ImageMagick is kind of really pivotal in some distributions of Linux. So for example, if you use the latest Ubuntu or Debian, you probably have it by default, and so does the containers themselves. So in this example where they showed it, they actually wanted to use to spawn a command that's an operating system command that's called convert, which is part of this ImageMagick library, to convert an uploaded file. Now, it makes somewhat sense in the Node kind of ecosystem, because Node is single threaded, and you don't want to block the event loop while you're doing something computational. You can solve it in different other ways, right? but they've chosen to just spawn an OS command, right? So this is interesting because it's not a unique thing that people do. Or if you're using a library for Node that maybe does conversion of images, how do you know if it's not basically doing the same thing, just like counting on what's going on there? So you have to like look at the README or look at the code and understand like what exactly it's going to do. The problem is ImageMagick has a ton of vulnerabilities, like literally, I think tens, if not hundreds of vulnerabilities over time. It's a pretty old project in terms of when it started existing, like decades. It's still like, mature and, getting active development, but it has a ton of vulnerabilities in different areas. One of them is this CVE, right? It doesn't look like very, sexy or interesting or, whatever. It doesn't look very attractive, if so to say. It's like, improper input validation, a lot of texture, a lot of advisory data. And indeed, when it was found, this specific vulnerability, this CVE, it didn't caught a lot of attention until the security researchers actually created a website called Image Tragic, and this is how they have addressed this vulnerability to kind of like draw some drama into it to make it a headline news kind of thing. And they've built this whole website that details exactly what the vulnerability is. The thing is, what is that vulnerability, right? I'm talking about it for a couple of minutes here. So let's go now into a running application and see what is actually going on there. It's a good time while I set up things here with the terminal, if anyone has any questions. I think I already have that. Docker build. Here, man. Okay, before that, let me show you what's going on. You're welcome to unmute if you wanted to ask anything. I have this code already here. Yeah. Okay. So I have this project. It's called, Goof container breaking in. I have this node projects one file because it's like super simple for this example. What it does is you can see it has some file paths to basically resize an image. That's what I want to do. I want to like build something that resizes images. I'm using the child process the same way that you'd expect. I have Festify as my web application framework. And I'm using child process, by the way, in a secure way, in a sense, right? I'm using exec file, which means I'm not allowing you to just execute whatever you want from user input and concatenate shell parameters and so on. So this is user bin convert. This is where the file output is going to be. So you basically accept of the image itself. You cannot control anything here. This is completely out of your control. By the way, this is not even a vulnerability in any like open source dependency of npm or node itself. This is basically me running an operating system command, just spawning a new process to convert something. So let me run this and show you what's going on. This is my Docker file. I'm using this a bit of an old version of Node, but just for the sake of the example, like nothing fancy. That's very simple one, very insecure one by default, but that's different story. So let's Docker see if this works. Okay, so I have this running 3112. 3112. There we go. So this is it. So overall, pretty simple, right? I have this ability that I can choose a file. It will click resize. It will basically resize it to this size. That makes sense. Let me show you a couple more things here. So let's look at, I'm going to choose into exploits. And this is one file that I'm going to upload. You can see what is going on there, right? This is not a normal JPEG file that you'd probably take a look at. This is because this JPEG file actually uses a capability, a feature of ImageMagick called image delegates, which basically means that it's an instruction to tell ImageMagick how to construct this JPEG. It tells it, what is the view box, what is the viewport, if so to say, how to fill it up with data, basically go to this URL. But look at this, it's actually kind of like escaping a command. This is basically a command injection, right? It's basically escaping this URL statement and says touch RCE1. So touch is a way to create files on a Linux system. If I do touch, ABC, right? This is going to be a new empty file called ABC. There we go. So this is basically what it's doing. And as you can see, this is what I want to basically do. So I have RCE1. I have a bunch of other things to show you in a minute. But let's see what happens when I upload it. Now, to show you what happens, I also want to go inside a container itself. So I have this running container here, right? Is there a question? Okay, no. So I have this running container on my left, right, and then on my right, actually, like now SSH in a sense into it. I open a terminal into it. It's not really SSH, but you can see there's no file called RCE1. So I haven't yet, this doesn't show the vulnerability yet, but we are going to do this. So the way that we're going to do this is basically uploading it, right? Uploading it, RCE1. I just chose a file and uploaded it. As simple as you would upload it to any media website you could think of. Basic functionality today, right? Uploading images, Instagram, whatever, all of those things. Let me go in. I mean, this was successful. Let's see what's going on in the container. Now I have RCE1, right? It's empty. I just touched it. Or I just created it from scratch. But look at what happened now. I was basically attacking a running container, disregarding any vulnerabilities related to the node app. Like I did not exploit anything related to the node or the vulnerabilities that exist in, maybe there are vulnerabilities here or in the packages that I use, but this is not what I exploited. I exploited the fact that this container image is built with open source dependencies, has probably hundreds of vulnerabilities in them. One of them is image magic. This vulnerability in particular that exists on this container version on the base image that I'm using. This is the base image. Where is it? Docker file. Node 610 Wheezy. If you use this, or by the way, maybe it exists in different versions. I don't know. I haven't tested all the hundreds or thousands that exist, but right, if you're using something that has this vulnerable version of image magic in production right now, you are vulnerable to exactly this very simple thing. Now, this is just creating, this is just touching a file. It's not, as impressive. So let's do something else. Let's try and create a reverse shell between the container itself, what's running right now in production, or in my case, in my environment, on my laptop, and into a remote running service of the attacker. So the way I would do this is, I need to, let's exit this one. Don't really care about it. At this point, I do want to show you more of the exploits. I have RCE2. Basically, I want to show you another example where in this one, what I do is I go ahead, again, try like the same concept of the payload. I try to tell it, get, the delegate gets, use curl or something to get the data for the image from this, which doesn't exist. I don't care about it because I'm able to inject this wget of, I needed to connect to my own host, a host in my control, and run this RSH script. Once you get it, you write it, just run it. That's the only thing that I care about. So to do that, what I need to do, as you see, it's already in my exploits directory here. I'm going to run serve, I can do -d. By default, it's going to take port 5000. So this is running on the container, right? This is image magic on the container, basically trying to do something with this image, convert it like my code is supposed to do, but it does something more. It's going to connect and download this RSH. Now this RSH thing, RSH, what this does is, well, I need a way to connect to the container itself. I would like to do that with Netcat, which is a handy tool, like a Swiss Army knife, the way it's kind of like being referred to for network operations. What I can do is, sadly, by the way, Netcat doesn't exist on that Docker base image, so I had to like find a source code for it, which I did. It's over here, actually downloaded as part of my payload. And so what this does is I've got like now a web server serving files. Once it gets this RSH, it will again connect to download Netcat. It will untar it, compile it. This is all running while I'm trying to like convert an image, right? That's like mind blowing. And it will open a shell to a remote port here. Let me do that, which this is just my host container itself. This is what I need. So I've got everything now ready to basically get it to work. So I only need to upload. Where is it? There we go. Yes, I do want to upload a new one. Let's call it RCE2. RCE2. Let's see. There we go. Now, a good sign here is that it's taking time to upload this file, of course, because it needs to basically do a couple of more things. It's not just doing touch RCE1 on the disk and that's it. It needs to actually download something. It needs to go ahead. Right now it's compiling things. How can we know if it's compiling something, right? We can Docker exec into the container itself again. And look what I have now. Like before I just had RCE1. Now I have r.sh. Now I also have some residue from the netcat itself and everything that's going under. Now at this point, what happened in the background, or if this was successful, is that the RSH script, which we saw before, should have opened a shell into this running window of netcat that's in listening mode. So I don't see like an actual prompt because this is just like a TCP tunnel. But if I just do ls-alh, like view what's going on, there we go. This is me now interacting presumably in a remote place, interacting with a running container that was vulnerable. You can see that the output of my ls was basically exactly where that script left off. Where did it left off? In the netcat directory compiling it. So I can do, pwd to see what's going on, right? All of these commands go back a few lines. And there we go. In the goof app, we can go inside and see exactly what we saw. So on the left here, on the bottom, this is me in my remote shell, basically seeing the same thing as if I just connected, with the Docker exec to like a local running instance. So I hope this was interesting to show you how issues, actually security concerns exist in our running containers potentially. If we're just running some insecure libraries that may have exploits in the wild, like this one. This I didn't even need to. I wrapped up this exploit in a sense, but I didn't discover this. I didn't research this. This is POCs and information that exists out in the wild. Actually on GitHub, you can easily find it, and anyone can basically, if they know it, can weaponize it against you. So I'll disconnect here. I want to show you another demo. I want to stop the running container. Okay, great. Let's clean up because I want to share a different thing. Okay, we'll get to it in a sec. Repos. Let's go back to the slides for a sec. All right, so this is, what can possibly go wrong with my vulnerabilities in my container, right? The other thing that, I'm going to move into another best practice here is using a linter, right? If you're using a linter, which is basically static code analysis on something like a Docker file, it can tell you a lot of the issues that, I've talked about here. Well, it can't find, and it won't find security vulnerabilities like SNYK or other tooling does, because it's not the purpose of this, but it will tell you if you're, for example, not using a least privileged user, right? If you're using deprecated tags like maintainer, if you have something like get upgrade, which is, it's like I said, I do not recommend doing this practice, but if you're doing it, then at least rebuild often. So using a tool like Huddleint, which is also like open source, you can just use it and run it on Docker files. It is something that you can easily plug in your Git hooks or CIs and just give your developers output, when they build the Docker file, not, much afterwards after you look at it and so on. So yeah, very easy to use. But now I'm drilling into that node application that I do have running, right? I have this application dependencies in my node app, and how can they actually impact a running container? Because they can. Because a lot of the times when we're building applications, state of mind is I'm writing code, and let's make sure that my code is not vulnerable, right? That I do not have security issues, security, bugs in my code, in the code that I'm writing, like SQL injection things or command injection where I'm not like sanitizing or filtering or escaping what's needed. The thing is, it's a good mindset, right? We should always, strive to create, performant code and, secure code and so on. But the reality is the code that we're actually building versus the app itself is really small, right? So my code has a very small footprint, maybe up to 10% in some cases, but 90% of the application that I'm building is actually built out of this open source dependencies that I'm using, like Fastify, like Express, like React, like all of those examples that you could think of from the node world. And those dependencies, as we have more and more of them over time, also we indeed, as we're seeing in this trend here, discover more and more vulnerabilities, in those, across ecosystems of these application languages all the time. But the thing is, it's not, I wish it was simple, but most of the time it's not, because there's a complicated thing here, where sometimes in some ecosystems, that you can see, it differs in this chart. Some ecosystems, we find vulnerabilities mostly in indirect dependencies, right? Like npm, like ruby gems, like maven. What it means is, most of the time when we find vulnerabilities, they will not be in what you are pushing into package JSON or the POM file, because it's going to be all of the dependencies that those dependencies actually bring in. So if I build, Express, and Express need a body parser, then body parser might have the vulnerability, but it's not explicitly written in my package JSON. So if I'm tracking the Express project or Angular or React or whatever, like top level project, that is great that I'm tracking it in terms of like looking at the change log and security issues, etc. But it's not enough, because for these ecosystems, most of the issues that we find at SNYK for users are in indirect dependencies. And you're probably asking yourself, what can go wrong with dependencies in my app? Like, how can it actually impact the running container again? So let's see an example of how does this work. I have this other application called the Goof App. Let's see. Hopefully it wouldn't blow up badly, because we just did another container running. I think it's okay. Yeah, listening looks good. With the new one here. Oh, it was yeah, there we go. This is a Goof App. It's a to-do app, for different things. But what I want to show you is it has some vulnerabilities inside it. Now, how do you even like find those vulnerabilities, right? How do you know what's going on there? So I actually imported into SNYK a couple of them, a couple of these projects. So this is the Goof App. You can see I have the package JSON for it in the Docker file. So Docker file, we talked about it before. When I import the project, now we detected that I have a Node 6 stretch, and it allows me to use different base images that makes more sense for me to use. And if this is what we talked about before, right? Like, these are all image magic I'll find here and all of these things, and then I will know which base image to use. But now we're talking about not just the Docker file itself or the Docker image, but the app itself. So this is the application itself. I just imported it, as one big thing. You saw I have like different like mini projects to this Goof App. I have a package JSON, take the Docker file, there's static analysis as well to help me. But let's look at the package JSON. The package JSON has a lot of dependencies. I have the same view as I have with containers. I can see which dependencies I'm actually pulling in and what vulnerabilities they have. So it looks like I have a vulnerability in a package called ST, which is a directory traversal. It has a little different stuff, but I want to show you the directory traversal path. This is basically a way to allow me to show files, to give you like HTML with some from static images from a running Node app. So in essence, what this means is if I go into this about page, you see public about HTML. I can put whatever HTML static assets here, and this will be like a static web server that serves this data. But to basically do that, I am using, there we go. Oh, it's just a sec. I am basically using ST. That's what we detected in my package JSON. So I have this package, which now I know that is vulnerable as a dependency, and it has directory traversal. Let's look at how exactly I exploit it. So I'll copy this to get started with. And I have this running container here in the background, and I can do it here so it's more clear as to the server and the command themselves. If I try to get the about page, making sure that this works, if I try to kind of like do path traversal and see what's going on there, you can see that, // doesn't really work, because this is not the attack payload. But if I encode this, if, the developer of ST, or, just haven't thought about someone encoding, URL encoding this dot, which is %2e, now you can see that it works. Now I broke out of the node root directory for public and into my actual application. So this is the actual Goof application that I just showed you. You can see the application JS and the package JSON. And from it looks like, well, this is just path traversal. It's nothing, important, right? It's not like I showed you before, remote command execution or whatever, remote reverse shell. But it's as severe as is, right? Like if I can look at what is in app.js, let's take a look. What's in app.js? Well, I can now access this file because this is directory traversal. I can see what's going on here. If, for example, you left a secret token or an API key lying around, a user and password into like the database to connect, I can have access to this. More than that, I can go and figure out, well, let's look in package.json. Let's see what you have inside. Now I know how you're running the application, which dependencies you're actually using, which versions. Maybe I can find now vulnerabilities in one of these to now escalate this attack from basically a patch reversal into something much more severe. So let alone, right, like accessing any configuration or whatever you have left on this base image, whether that's the .npmrc or API keys in some file. So this is basically me now being able to access the running container and data inside it from a vulnerability in the application itself, like a patch reversal. So taking us back into kind of like summarizing all of this. So we talked a lot about, different best practices from, scanning the container, the application itself, understanding there's like a holistic view that we need to have for security for cloud native applications, like basic, Docker images built out of, built for Node, for example, running in the cloud. And, we talked a lot about, some practices here. I'm going to leave you off with, if you go to the SNYK blog, there is this Docker base image security best practices thing, which advises a lot of what I just showed here, but it also takes you, step by step. I also just recently published another cheat sheet like this. It's a cheat sheet, but it's a blog, which is like you have a written thing so you can follow along for Node.js, which has been receiving a lot of like good and positive feedback. You can go and check this out on the SNYK blog too. And I'll leave it for, got a couple of minutes before we end. If anyone want to have any questions, for me, I want to say thanks for joining. It was a great session and a great time meeting you all.
Liran.
Yep.
Yeah, thanks for the session. This is Giri. My question is around the distroless images. What are your thoughts about that? And using that reduces all the risks that we discussed.
Yep. So if SNYK scans it, which it does support, it's going to give you some output that might still be relevant. And you're right, probably like if you're using distroless images, it might, it's a good step in terms of just having a lower attack surface of, less vulnerabilities and so on in terms of like the dependencies, because it's kind of like clean without them. But at that point, you could still have, some binaries, artifacts that you pull into it, which, SNYK can look into. But maybe more importantly, the runtime itself. So maybe I have other examples where if I'm using like a vulnerable Node version, the Node version is actually vulnerable. So a lot of people maybe not even thinking about it, right? They're just using Node, 6 or Node turnaround, whatever. They're not really thinking, well, I don't have issues with dependencies, nothing on the container itself, but wait, the runtime is actually vulnerable. So that is still the case. But yeah, I would say if you're starting off with this role, that's probably a really good starting point in terms of just lower attack surface. That's a really good observation there, Gary. Any other questions? I think we still have a couple of minutes. Oh, there's something.
Hello, Mohammed here. There's just a question around what terminal software thing that you use in there. What app's that? It's unrelated.
It's always that, right? It's like, which font are you using for?
I know.
No, it's a good one. So I actually like this one. This is ZSH with autocomplete from the official. And I actually believe I did remove official. And this is basically, oh man, I forgot this. It's, let me send it in the meetup chat. This is basically an open source project called, is it Spaceship? Always.
Oh, okay.
You know what I mean? The spaceship prompt.
Yeah. Okay. And is that item that you're using there?
Starship prompt, sorry.
Oh, the actual prompt called Starship. Oh, okay.
Yeah, Starship.
Okay, cheers.
Sure thing. I can put it in the chat. I just found the website for it. There we go. It's open source as well. All right, cool. Well, I think we'll kind of like probably wrap up. Thank you for the questions. Thanks for staying tuned. I hope this was interesting. If you want to chat, catch me up on Twitter at Liran_tel. If I can help with anything, have any questions about SNYK, you can just get started. It's free, and for open source and private packages project. So if I can help with anything to onboard you or anything like that, shoot me a question. And thank you, Joe, for inviting me, and for everyone else for tuning in.